Okay, so welcome everyone, and I am extremely pleased to introduce my our next guest, who was a great friend of mine, from Roger Azevedo, not nearly as lovely a pronunciation as Sue's. So Roger is a professor in the School of Modeling, Simulation, and Training at the University of Central Florida. I've known Roger for a very long time because Roger is actually a Montrealer, and did his PhD at McGill and his master's at Concordia University, which is where I first met Roger many years ago. Roger is an incredibly informed and scholarly researcher who does work in the field of both cognition as well as metacognition, and also in computer science. He's affiliated with the departments of computer science and internal medicine at the University of Central Florida. He is also a lead scientist in the Learning Sciences Faculty Cluster Initiative. So straddling these different faculties, Roger has a deep amount of knowledge about both the practical as well as the theoretical ways of thinking about learning and learning metacognition, and how that works with tools, the tools that they are advanced learning technologies, in particular, things like intelligent tutoring systems, hypermedia, simulations, serious games, virtual learning environments. Those are things that he has been well known for throughout his career. Roger has written over 300 peer-reviewed papers and chapters in some very important works, as well as many conference proceedings. He is, in addition to all of these things, Roger has gained prestigious awards, one of them being the Early Faculty Career Award from the National Science Foundation, which is an amazing accomplishment, because the National Science Foundation is got a lot of very high demands on how they award people for this kind of acknowledgement. So without further ado, I'd like to pass the mic over to Roger and thank him so much for being part of this important series for us, which is bringing the learning sciences, education psychology to the Salties community, and in particular bringing these renowned scholars and their specific field. And as I said, Roger's is metacognition. This is a really important part of understanding how we promote learning and how we promote learning in the areas of self-regulation. So thank you, Roger, for accepting, and look forward to this wonderful presentation.
Well, thank you so much, Liz, for the invitation and for your kind words, and also to your staff. I mean, Phoebe and Sue and several others who I've met in preparation for this. So let me start with sharing. Hopefully I got the right one now. Screen two. Can you see that?
Yes, all good.
Okay, perfect. And then I'm trying to see if I can see everyone. Yeah. All right. So yes, well, thank you so much. It's a pleasure to be here. Too bad I'm not there in Montreal with you. I miss my hometown. But thank you so much, Liz. And then if you have any questions, let's make this interactive, right? So you don't have to sit through this and hold on to your questions. And so I'm not able to see your videos, but or your faces, but please do interrupt if you have questions. Okay. And I'm assuming everybody can hear me.
Yes, we can.
Perfect. Thank you. So yes, so we'll spend some time talking about metacognition and self-regulated learning. Sometimes these two terms cause confusion because, are they the same? Are they not the same? Are they related to each other? And they're also used sometimes interchangeably, so causing more confusion, not only for researchers, but also for educators and instructional designers. So we'll talk a little bit about what, are they the same? Are they different? How are they related to each other? And then also in terms of our presentation today is really focused on not just the theory or what these models look like, because I think that's part of the sharing so that you understand how researchers conceptualize this, including educational psychologists, learning scientists, and educational researchers, but also then how do we apply these to different technologies in terms of the system development, the kind of feedback and scaffolding that students can receive, et cetera. And then also I have to, acknowledge all my funding agency. Most of our funding here in the U.S. is from the National Science Foundation and also the U.S. Department of Education, NIH. We've also had Fulbright. And then we're still publishing on some of the work that I've done when I was a CRC tier 1 faculty at McGill, and also some of the work that my former advisor, Suzanne Lajoie from McGill, we are part of this LEADS project, which also had 21 people around the world. And some of this work was also funded by NSERC when I was still there. And more recently, we have some international collaborations, so that are funded by the EARLY, which is the European Association for Research and Learning. And more recently, we have an AI for Kids virtual center with some of our colleagues in Australia and Europe, and that's from the Jacobs Foundation. So to kind of jump in terms of an overview, we'll talk about the fact that, so when I met Liz, I was a student in educational technology at Concordia. And, one of the things that we usually grappled with, it's easy to be enamored and seduced, if you will, by new technologies. But the question is, what led me to go to McGill was that, at the end of this, there is a human involved. There is a human in the loop, and we can't just focus on the technology and the features of any technology, because that's easy to do. But the question is, we need to understand how it impacts the human and what the human brings to the technology, right? We'll focus a little bit on metacognition and self-regulation, talk about those, how do we measure those, and then what are the implications for the design of different types of technologies, whether it's serious games or intelligent tutoring systems, and several other technologies. So that's a little bit of an overview. So we always start with, I know this slide says self-regulation, but forget about that for now. We'll replace the SRL with metacognition because the framework would be the same. So we start with some theory, some model, some framework of self-regulation and metacognition. We then use that and apply that to a particular context because learners, humans, are using some technology, for example, a game-based learning environment. So whether it's a middle school kid, a high school student, a college student, we work also with physicians, nurses, critical care physicians. Sometimes these technologies are also not your typical technologies. So, for example, when I was at McGill, we did a lot of work in the Medical Simulation Center, which is situated underground in La Cité, where, for example, we're looking at end-of-life scenarios. How do you train physicians and to prepare to deal with death in terms of end-of-life scenarios with high-fidelity mannequins, right, that actually talk and emote. And then we focus a lot on measurement. So we'll spend a little bit of time talking about measurement because measurement in terms of self-regulation and metacognition has unfortunately been dominated by using self-report measures. And while self-report measures are fine, they're really measuring students' perception of their metacognition or self-regulation. And we would rather use multimodal data. So while we don't throw, those self-reports away, we're more interested in also collecting eye tracking data, physiology, verbalizations, posture, gestures, etc. So we'll share a little bit of that to whether those specific measurements of multimodal data are indicative of particular metacognitive and self-regulatory processes. Then we analyze that multimodal data, and we're not going to spend too much time on that. That's more like, how do you analyze the eye tracking, the physiology, the face? And then the question is, once we have an understanding of what the students did and did not do in terms of metacognition, self-regulation, then we try to make those systems more intelligent, right, or adaptive. And then that also basically increases our theories and models of self-regulation. So we tend to go in this cyclical cycle. So, when we take some, you might be used to, okay, well, if you have a tutor or a parent tutoring a child, for example, they're doing their homework, right? The question is, well, where is the metacognition? Where is the self-regulation? Is it in the child? Is it in the person who's more able? In this case, this could be the parent or the peer, not the peer, obviously she's much older, but the parent or the tutor, right, or the teacher. Same thing, for example, in a medical scenario. So, for example, in hospice, when you have end of life, right? So so if you have a more experienced nurse, this could be the physician, that could be the nurse. There, in this case, it could be, you're showing empathy. Is empathy related to metacognition, self-regulation? Who's doing the metacognition, self-regulation? Same thing, medical training, or you have a medical team, and it could also be other real world, not K-12. So, for example, here, if you got the pilot and co-pilot, right, then who's doing the metacognition and self-regulation? Is the co-pilot the one who's watching the pilot? So can they detect some aspect of what the pilot is doing that may be, erroneous and cause, potential harm? And so then the question becomes, who's doing the monitoring and what's the difference between monitoring and regulation? And of course, so that can be applied. So in other words, this slide is basically trying to show you that basically metacognition, self-regulation are applied to really any situation. Doesn't have to be K-12, right? You can have military. We have a lot of military folks and officials that come to us. We're surrounded by the 5 branches of the military. So there's a lot of work in terms of team dynamics and scenario, but also think about the future. Right. So, for example, when one of the research agendas that part of our research agenda is the question of, can we develop human digital twins that not only observe humans, but then can they have human level intelligence, or at least try to mimic that, or human? So the question becomes, can an artificial agent be metacognitive and be able to self-regulate oneself? So it applies to a lot of situations. If we think about this in terms of self-regulation or metacognition, so one of the things that we ask is, these are both psychological constructs, right? So the question is, what is self-regulation? What is metacognition? Okay, and then we're still going to get back to that. I'm still trying to tease you about the differences, right? So the question is, what are these processes? Because these processes occur at the neural, cognitive, affective, metacognitive, motivation, social, and contextual processes, okay? So the question is, when also are they happening? Why are they happening? So as educators, we need to understand, if a student is not on task, if a student is failing to comprehend, let's say, a physics word problem, or doesn't understand how to balance a chemical equation, the question is, what is the issue that that student is having? Because we need to understand. And then the question becomes, what are the indicators? Are they even monitoring? So the metacognition relates really to the monitoring of what they're doing, right? And assuming that you are monitoring your understanding as you are reading, as you're inspecting a diagram, as you are talking to someone else, if you are really monitoring, right, in real time what you're doing, then the question becomes, if you have an awareness and you're monitoring, then the question is, do you have the skills to regulate? So if I'm reading about atoms in a chemistry book, and I'm reading really fast, and I'm not understanding what I'm reading, the question becomes, when and how does a student know that they don't understand? And once you've reached that point, because that is the monitoring, then the other question becomes, then if I don't understand what I'm reading, because I can't differentiate between what's in the nucleus and what's outside and what the heck is a K shell, right? The question is, how do I then regulate? And the regulation revolves around the specific use of strategies, a learning strategy. So the question is, do I go back and reread? Do I go back and inspect a diagram? Do I try to coordinate what I read with a diagram? And maybe I have to take notes. Maybe I have to rewrite. So that's kind of the balance between metacognition, which is really your monitoring, and the regulation, which is really the strategy use. Okay, and we'll show you those in other models. And what we try to do is, we're doing work, for example, with several schools here in terms of VR, using VR for chemistry, right? Is it effective? Like when a student uses VR, well, now I no longer have access to their face, right? I may have access to the verbalization. So are they expressing regular monitoring through what they say? Like, I'm not really getting this. I don't know how to synthesize this new compound. And the question is, if they're moving, right, with their devices, and the question is, are those the regulatory processes because they're very chemistry specific? Or when a student is alone, right, doing homework, versus what does metacognition self-regulation look like when you may have 2 agents, like at the bottom right here, where you have 2 students basically working on a high-fidelity mannequin. One of the things that we're also careful about, because we see this a lot in the literature, especially in the educational technology, educational research, learning sciences, is that a lot of the work so for example, take chemistry, the top right, for example, we typically give them pre-tests that are paper-based. Then we give them a post-test that is also paper-based, right? But here if we're looking at your ability to know how to read a meniscus or how to use a pipette, what we've done is that it's not good enough just to assess learning from pre-test, post-test that is paper-based or Qualtrics, is that if you see the bottom right and the bottom left here, is that part of the pre and post is that they actually have to have wet labs. So we work with the chemistry faculty to create wet labs because we want to see if you can also transfer your skill from the VR to real life. Okay, so going along with that, so what are some of those issues that we see in metacognition, self-regulation? So going back to Marcel Wieneman, who's now retired, when the first issue of Metacognition and Learning Journal, before I took over as the editor, what we're seeing a lot in this literature is that we argue about definitions, because if you're in Europe, right, they're more likely to call it metacognition. If you're in North America, in the US and Canada, we tend to call it more self-regulation, but they are different, and we'll see that in a couple of slides. Okay, so what is a definition? Where does situational awareness come in, right? You have to be aware before you monitor in order to regulate. And then we make it even more complicated, because then people talk about reflection, right, in terms of teacher practice. Oh, teachers reflect. And I'm like, well, what's reflection? How do you know a teacher or faculty has reflected? What does that look like? Okay, what's the evidence for reflection? What are the components of metacognition? You'll see that the components are very complex. In fact, there's one person who did a PhD, her name is Pina Tenerico, over a decade ago, and I'll show you her model. Okay, what's the relationship between metacognition and cognition? Because if you have metacognition that basically monitors and controls cognition, then we have a meta-affect, because emotions are also part of learning. You have a meta-motivation, right? And the question then becomes, my gosh, how big is this tree, if you will? Is it conscious or automatic, right? So if I am learning physics, I'm a new student, I don't have much physics background. So is my metacognitive process or processes of monitoring much more conscious, right? Because I'm aware that I don't understand that physics problem related to, let's say, Newton's second law. But if you're a physics faculty, you're probably not even aware, because your metacognitive processes have become automatic, right? And the only time they actually become conscious, if you will, is if perhaps if you're explaining something to a student. So you're uncompiling your knowledge to be able to teach and disseminate. At the same time, developmental processes, right? We know from the literature that, students, humans in general, don't really develop metacognition until they're about 5 to 7. They tend to be very egocentric, right? Until you develop a theory of mind. All of a sudden you're aware that you do have a cognitive architecture, and that I have a memory, and I can actually manipulate that memory, okay? And I have a theory of mind, so I can actually interact with another human, whether it be a peer or a teacher or a parent, right? And actually I can detect if they understand what I'm saying or not through facial expressions, etc. So development processes are really important, okay? And then we have the assessment, right? For us as faculty, as educators, we're interested in how do we assess metacognition, because when we look at the literature on teacher preparation and teacher education, teachers are not in general, right, in pre-service teachers, typically are not taught about metacognition. So if you're not taught about metacognition, now you're in the classroom and you're trying to assess students' metacognitive processes, how are you going to do that? Because a lot of this, unless they're verbalizing it, unless the student is saying something like, you know what, I don't understand what that diagram, okay, is relevant to my current goal. Unless the student is so explicit, it's all covert, okay? And if it's covert, then how am I supposed to know why they're not getting their problems correctly solved? The other question is, so this begs a big question in terms of the acquisition, how do we acquire, and then how do we teach? How many of us actually teach explicitly a student, for example, how to engage in metacognition? What kind of modeling would you have to do? And then there are individual differences, right? So you may be able, have the potential to metacognitive monitor and regulate, but you may be a novice or you may be a young child, and so you can't get it. So you need to have some kind of external regulating agent to help you. Also the emotions. If you have low emotion regulation, and that's occupying obviously your working memory, then you're not going to have much room, if you will, for engaging metacognition. Also, your motivation, right? Student says, well, you know what? I hate physics. I don't really like physics. So, I don't care, so I'm not going to monitor. Even though you have the potential, you're still not going to do it because of your belief system. And then there's a little bit of my psychological work, and then we'll talk a little bit about the role of metacognition tools. Okay. So just not that you have to memorize this, you're not going to be tested. So just to give you kind of a little bit of a landscape in terms of, I want to show you some of the models that exist. So when we go back to the earliest model, is that any human, there's a meta level, which is that monitoring. So for example, the object level is what you're doing. Let's say you're taking notes in class. Let's say you are reading your chemistry or physics textbook. As you are reading, as you are monitoring, as you're taking notes at the object level, which is the thing that you're doing at the time, you're potentially monitoring what you are doing, okay? And if you are, then you're actually creating a model that, for example, hey, I don't even understand the notes I'm taking, right? So the question then becomes, or I understand this particular concept, right? Oh my gosh, this Krebs cycle is really complex. So then the question becomes a control. So from here, as you can see, this basic diagram is that difference is that monitoring is when you are studying, when you are reading, when you are learning, when you are reasoning, understanding, etc. There is an assumption that you are monitoring at the metacognitive level. And then if you are aware, the question is, can I regulate, which is the control. So the control is equated to regulation. So that's just one simple model. In terms of computer science computational modeling, we get into a lot more detail because they have to be very specific, and I don't want to bombard you with all this stuff. Okay, so there's monitoring, evaluation, planning, et cetera, but just want to mention that there is work in metacognitive architectures that tries to do this in robots and artificial agents. But then more importantly for us, as in terms of thinking about us as instructional designers, educators, et cetera, is that their assumption is that metacognition actually is an umbrella. There are many different types of metacognitive processes. It's not just about monitoring itself, right? So for example, the assumption is that when I'm learning about something, so let's say a student is learning about a new topic in chemistry, physics, biology, right? So you're acquiring knowledge. So let's say, wow, I'm just learning about mitosis and meiosis. It's like, okay, so the assumption is that during the early acquisition of learning, that, students make what we call ease of learning judgments, right? It's like, okay, well, I don't know anything about mitosis. So the question is, I'm about to learn about it. So students make an assumption of how easy is this going to learn, because that's going to drive your metacognition and how much effort you're going to put in. And also what kind of strategies, assuming you have those learning strategies, right? Now, while you're learning, so let's say now you're jumping into mitosis, right? I'm on the third page, I'm working on this lab. And you know what? Judgment of learning is, I don't understand this. And that's a typical expression. So if I don't understand this, then the question becomes, well, how are you going to regulate? So the bottom part of this figure are just 5 of many different types of cognitive strategies and learning strategies that a student can use, right? Some of them are generic, like rereading. Well, sure, if I'm reading and I don't understand, I'm not developing a mental model, let's say, of how, an ionic bond works, then I may want to go back and reread the text, right? So rereading, you can use rereading whether you're in physics, chemistry, biology, history, doesn't really make a difference, right? So this is basically that along the line, so from retention to retrieval, there are different, and these are just 5, both monitoring and 5 control strategies that students can use. If you're interested, I can share with you, we have long lists of those, okay? Here's what I was trying to show you. So when Pina Taricone did her dissertation, she actually got a book from Academic Press. So this lives as a book. Her dissertation is actually a book on the taxonomy. It's called The Taxonomy of Metacognition. She has actually synthesized, did a wonderful job of all the areas of the literature that are focused on metacognition. So everything from philosophy of science to science education, learning sciences, ed psych, etc. And what she did is, I love this image because this figure really shows you the complexity of metacognition. And if you think about it, right? Here at the center, you have the knowledge of cognition, which is the metacognitive part. And then you have the regulation of cognition, which is the self-regulation. Okay. So, but then in summary, we're not going to spend too much time on this. And again, I also have this, I can share this, is that you are metacognitive monitoring and regulating the self. So you as a learner, right? It could be others. It could be the task. Okay. And then other things that sometimes students have no control over. So for example, the amount of time they have to study or the amount of time they have to do a test. Okay. So it breaks down into these different components. Again, just wanted to show you that there are computational models. So our colleagues at Wright State University, so Michael Cox and some of his former grad students have developed computational models of metacognition, which are way more complex than the Nelson and Aarons, but they are based on still the object and the meta level, okay? And they have actually computationally modeled these in artificial agents. So you can actually develop an artificial agent of a student and simulate how they would engage in metacognition and regulation, right? So moving right along. So then here we have Paul Pintridge, who was one of the leaders, passed away over a decade ago. So what he did is synthesized areas of self-regulation. So we're kind of now jumping into self-regulation to show you the flavor that this is kind of the North American perspective. So what Paul basically did many moons ago, over 20 years ago, is that, you know, any student has the potential to monitor and regulate. Does not mean that they actually do it under all instructional or learning contexts, right? And the assumption is that you can regulate your cognition, if you think about the columns, your motivation or affect, even though nowadays we would actually separate these into two separate columns and treat them differently, your behavior and your context, right? And then if you go across the rows, is that you can think about that there are different phases. The first phase is, hey, I'm going to be learning about balancing chemical equations. All right, well, what do I know about that? So I'm activating you should activate your prior knowledge. How do textbooks do that? Do they do that? How does a faculty member, right, a teacher do that, right? As opposed to letting students do that. So forethought planning, right? So, okay, so I'm given, an hour to study about ionic bonds, given this particular textbook or PDF file, because I'm using an LMS, right, before I get into my lab. So how am I going to plan for those? What kind of sub-goals am I going to create? While I'm doing that initially, then, all right, well, let me start now getting into the instructional material. It could be a computer simulator, a lab, a serious game. It can be text. The assumption that you're metacognitive monitoring, right? And there you go, the control, adapting and using strategies. And then depending on the kind of environment, is it a learner-centered, right, or teacher-centered? Are you allowing the student to, after they've done, let's say, learning after that hour, are you helping them reflect on what they've learned? Are they reflecting on their planning, right? Are they reflecting on, did I actually use good metacognitive strategies? Was I effective in using learning strategies, right? And most of the time we don't get to this. And so this means that you can actually plan and activate all of these processes, right? And so think about each of these cells in this 4x4 grid, right, as areas of research, actually learning sciences and educational psychology, cognitive psychology, etc. And then some folks have actually dedicated their entire lives to one of these, right? While some of us have actually spent time looking at these. So for example, if you look under behavior, and if you can see my mouse, if you look at under behavior, there is help seeking, right? That's here, that's under control. That's when, hey, I don't know how to monitor, I don't know how to regulate, I'm having a hard time understanding this stuff. Who am I going to ask for help? Some people, like for example, our collaborators or colleagues at Carnegie Mellon have actually devoted tons of time looking at help-seeking behavior and what does that look like in an intelligent tutoring system to learn things like programming, algebra, okay? So this is kind of an overview, if you will, so in terms of self-regulation. But as you can see, even though it's, again, here's part of the problem, even the title, you can see it's like phases and areas of self-regulation, but really, well, there's the regulation is actually row number 3, and they still have monitoring, right? So Then we have other models. So this is one of the typical models. It's more motivational, if you will. So Barry Zimmerman and who's retired, and Dale Shunk. But you can see the same similarities, right? There's a forethought, right? And then there's a performance where I'm actually doing the stuff. And what they call it is, they call it self-observation. Okay, am I engaging in metacognitive monitoring? Okay, and the regulation here is all these strategies that you could potentially use. So these are some of the interesting strategies. So for example, if you think about STEM or some of the, the topics that you teach your students, would imagery make sense? Or for example, task strategy. Well, what specific task strategy do you need to teach your students, or are you expecting your students to use, right? For example, when they're balancing equations, right? And are those strategies just specific to balancing equations, or is it a specific strategy that can be used in any other type of, let's say, chemistry problem, right? Or even more importantly, is that specific strategy used, for example, in biology or chemistry or history, right? This is one that we tend to use. This is the most the preferred model, just because it is a process-oriented model. But look at what's in the middle. The hub, the central core of Winnie and Hadwin. So Phil is about to retire, unfortunately. He's one of the leading scholars. He's at Simon Fraser University. And then this was developed initially in 1998, while Alison Hadwin, who's at the University of Victoria, was a student. So we have the Winnie and Hadwin model. This is one of the ones where it is really focused on the core is that students are monitoring and regulating. But look what's happening. You monitor and regulate, and you only control when students have standards, right? But here's the problem for us as researchers and educators, right? A student may look like they're not regulating or monitoring, but maybe they don't know how to do that because they don't have standards. If I'm just learning about chemistry, I've never done chemistry, I don't know what good comprehension looks like for what you as the instructor are expecting me to learn from this text or from this simulation about chemistry. So the question is, how do we teach? And we don't usually do this. How do we teach students those standards that you should be using to be able to monitor and regulate, right? Your understanding, your learning. And so that's one of the things I just wanted to focus on, that is like, how do we get to understand student standards? And are we, as part of our explicit instruction, should be teaching them that there are different standards for understanding and regulating. If you're interested in a comparison, we have Panadero. Ernesto Panadero is a researcher who did his postdoc at the University of Oulu in Finland, who is now a faculty in Spain. He actually did a really nice job. It's a 2017 paper. So all of these papers I can share with you if you're interested. He did a nice comparison of the top 6 models that include mostly cognition, metacognition, but some of them are also motivation and emotions, right? Because even though we're focusing on this talk on cognition, metacognition, we can't ignore that emotions, motivation, and social aspects of learning are also important. So how do we measure this? So I wanted to show you is, before we get into like multimodal data, is here's a typical, this is the most widely used self-report measure, okay, that was designed by Greg Schraw and Dennison back in 1994. It's called the MAI. It's got 52 items, right? And the students are reading these items literally. So for example, let's look at question 1. I ask myself periodically if I am meeting my goals. And you're supposed to indicate true, yes, or false. But think about these, right? What comes to mind? It's like, do I understand the question? How many instructional conditions or how many instances while as a learner have I experienced this? Does this apply to all my learning, to all my classes, right? And then I'm supposed to put true and false, right? So we can say the same thing for all of them. Am I good at organizing information? I have control over how well I learn. Well, that depends, because in some classes, it may be a student-centered class, and the other classes may be a teacher-centered class. So this is what I mean. So the question is that these are self-report measures that have been traditionally used. They're really looking at is a student's self-perception of their metacognitive processes. Okay, and we'll get back to how we handle that by treating them as self-report. And of course, this has a scoring rubric where you get 3 different scores on your knowledge, of declarative knowledge of what is metacognition, how do I regulate my metacognition, and then the conditional knowledge. Okay. So wanted to show you that is, I'm just going to pull this up. One approach that cognitive psychologists have engaged in to study metacognition, especially in STEM areas, is that, so now that I showed you, I'm going to pull this back, is that, we ask a student a question. How does gravity affect the motion of a ball that has been thrown in the air? That's all you're getting. You have a question. I'm not showing the instructional material or the instructional technology that you may be using. And we ask a student to do an ease of learning. So how easy do you think it'll be to learn this information needed to answer this question? Well, you haven't shown me the information, right? So then we ask a student to make that judgment. Okay. Then we give the student the content. And the content could be, for example, 3 paragraphs and a graph. It can be a simulation. Right. After they see it, we ask the same question again. Right. The assumption is that, and they do the same, you can do the same for text, you can do the same for graph. And then there's a delay because we want students to really think about the question and think about the materials. And now the question is, well, now that I've given you a delay, are you going to be more accurate, okay, in your metacognitive judgment? Right. Then they do the same, okay, and then we ask them the question, right? The students get the response. They spend instructional time trying to answer this question, right? And then they get a response, right? It can be either multiple choice or they're doing a short answer. And then we ask what in the literature is considered an RCJ, or a retrospective cognitive judgment. So the question becomes, now that you've answered that science question, how confident are you that the answer you provided is correct? Okay. And so sometimes what we do is then ask them to justify, right, their answer. So this is one typical approach that textbooks can use, faculty can use when teaching, for example, live, and that can also be embedded in any kind of technology, especially if you're using, for example, a simulation, or if you're using kind of older technology, if you will, multimedia or hypermedia. So here's another version. We have a version of MetaTutor. I'll show you the original MetaTutor later. So, here's an example, right? So you give, please explain how the body delivers more oxygen to muscles than other organs during exercise. So the student has text. So the assumption is that they're reading. They have a diagram. And we've gone as far as, in some cases, that's all they had. And in some cases, we've started introducing either our live teacher, right, or a digital version of that teacher. So this is a digital version of an actress that we had. And then we're trying to use the face, whether it's happy, confused, right? The confusion is like, no, you think that this text and diagram makes sense, but it actually doesn't make sense. Or versus, yes, this text and diagram are corresponding to each other, right? And they do make sense. And we also try to dysregulate, because this is also part of an experiment, is by showing neutral face. Is the neutral face actually dysregulate a student from their metacomprehension? So, in other words, avatars, right? Especially with facial expressions, the question is, can you use the face to actually trigger some of the metacognition and self-regulation in students, or can you dysregulate them? Now kind of jumping into, all right, that's self-report. So here is a video of the multimodal that we collect. So part of this, what I wanted to show you here is, here's an example of a college student, one of our college students, who is using Crystal Island. That's a serious game. And in this case, what they're doing is we're just capturing this little snippet, okay? It's almost a minute of a student's eye tracking data. So this green that you'll see here is the student's live eye tracking data as they're reading this text that's embedded in a game on viruses, okay? So this would be real time, okay? So the question is, we see this as researcher. This eye tracking data is being fed back to us, okay, in a more quantitative way. Okay, but the question that we pose is, imagine now in the future, so there are laptops, for example, that already have embedded eye trackers. Imagine you are the faculty, the teacher, right? And you had access to a student's eye tracking data. Can we use eye tracking data to understand what a student read that you were expecting them to read? And if now, after they're reading, now they're being asked, just, show me the characteristics and activity, and just tell me the difference between viruses and bacteria. Imagine a student got all those wrong. The question is it because they didn't read something correctly or they missed a paragraph? You would only know that if you had access to the eye tracking data. So the question becomes, can we use this kind of eye tracking data for assessment, for enhancing the faculty's understanding of their students' reading comprehension? Okay. At the same time, can we also repackage this kind of eye tracking data to students so that you can see that the fact that you actually missed a paragraph, okay, that was actually key for your ability to understand the difference between viruses and the kind of activities that they do. So that's just eye tracking. Okay.
Roger?
Yes, absolutely.
Could we pause for a question?
Absolutely. Mm-hmm.
Okay. Liz, did you had a question? And if anyone else has a question, this might be a good time.
Yeah, absolutely. Yes.
Okay, great.
Yeah, so Roger, first of all, this is amazing because you're giving us like this master class in understanding, trying to understand the differences between metacognition and self-regulation. And I'm wondering, I'm asking myself how self-regulating my colleagues are right now, because I'm asking myself if I really understand. So I'm gonna to take the jump and say that I know others will ask questions if I start. But could not to disrupt the flow of your slides, but just for a moment, go back to sort of a more simple sort of beginning of trying to understand. You talked about the monitoring,
yes,
and then the regulation. So yeah. So how do we start teasing that apart as practitioners, as teachers? Okay, yeah, and then maybe you can talk a little bit about, you also mentioned that there are all these strategies that we could use.
Yes.
But like, how do you do strategies when you don't know if people are monitoring, I guess?
Absolutely. So no, that's great, Liz. No, thank you, and thanks for stopping me. Yeah. So let me use one of the. Let me go back to one of the slides. So for example, let's say you're introducing, you're teaching body systems. So let's say you are going to introduce this question. So you can be in class, right? Let's say you're introducing this question because it's related to what you're going to be talking about, right? So one way to actually teach students metacognition is that you can actually, I'm going to model it now. So you're going to be, a faculty member, a teacher would have to be this explicit. So, so I'm going to model what metacognition and regulation is right now for you for the class, right? So I'm going to start by using this specific example where you see a question. Here's the question. Please explain how the body delivers more oxygen to muscles than to other organs. So what I would start as a self-regulating student is I'm going to start by reading the text. So erythrocytes, red blood cells, RBCs carry oxygen through blood vessels in all cells. And now I'm going to stop. I'm going to ask myself, do I understand the information that was in that paragraph, right? And so if I don't understand, that sentence, then I'll continue to accomplish this task. Erythrocytes make a protein called hemoglobin, which holds onto oxygen O2 in tissues that are, right? Wait, I don't understand what that means. I'm trying to put the two sentences again, and I really don't understand what that means. So wait, you know what I'm going to do? I'm going to use a strategy. I'm going to go over here. So it looks like the instructor provided a diagram for us. So I'm going to go and see. All right, so hold on. Are erythrocytes found? Wait, but they're not even in the diagram. Okay, wait, what about hemoglobin? Is hemoglobin in the diagram? Wait, I'm really trying to understand this. And I don't think the instructor has done a good job because they didn't include hemoglobin or erythrocytes. And I'm really confused because I'm seeing other things that I don't understand. And I'll stop there. Does that make sense?
That's beautiful. And Michael just put in, you're doing meta modeling.
Yeah.
Very, very nice.
Yeah,
very
no,
nice.
Thank you. Yeah. But see how hard it is? I mean, it's so, think about it from an instructor's perspective, right? I mean, we don't do this because it's exhausting.
Yep.
Right. But this is what we need to do for students, right? because they don't get that. But imagine, even if we did that, because it is exhausting, you can actually, what I was just modeling, we can actually capture that, right? And then students can see it over and over again, so that we don't have to do this every class or every 5 minutes or 10 minutes. Does that make sense?
I think that's a fantastic, I never even thought about that, capturing on some video so that students can have this access, easy to access. Do people, those of you who are teachers in the crowd, are you curious about what Roger just did? Just use your mic probably, if instead of putting it in the chat.
And we have a question from Michael.
Hi, so yeah, so not, I don't, it's not, my question is not on that point. So, but it did have to do, like, I was really struck by the explicit nature of the importance of communicating the standards to the students and having them develop that idea. And that's something, I will honestly say that I probably don't pay enough attention to that when I try and give metacognitive prompts to students, like, hey, have you considered this, and how well do you think you've learned this, and what do you think you need to look at in the next class? So that is so yeah, I guess, and in there you also face that problem of having the students being understanding what it is you're communicating on that level. So it becomes another loop to this to this learning and regulating. Have I learned what these standards are, and if not, how do I get them clarified in that control process? So this is I was hoping a question would sort of.
But Michael, what you brought up is really interesting, because we can add on to that is that basically, so, and then you notice I implicitly went and regulated by trying to use a strategy that is in the literature, which is coordinating informational sources. Like, so I'm trying to go back to reading and look at the diagram, right? But then imagine you can ask the students, right, and make this more interactive. Okay, so now I model and you get to practice, but yes, on the second time around is, all right, if I encounter the same issue where I have to now coordinate text and diagrams, that's only one strategy. So now I imagine engaging the students, like, so what other strategies would be effective, right, to deal with the fact that I didn't understand the first two sentences? So there's ways of bringing the students in, because at the same time they can actually reveal, maybe they don't have any other strategies, that's the only one they know, right? But then I'll give you as a faculty member an opportunity to, hey, there's actually 2 more strategies, and now I'm going to model them for you. Does that make sense, folks? Oops, I'm not hearing anything.
We have a question from Annie Allen.
Okay.
Michael, did you want to say anything on top of that? You're good? Okay, Annie Allen then.
Yes, to answer, I guess, Liz's questions, I've never done it that explicitly either. And I kind of realize now that I assumed that was somebody else's job. Like they would have done it before, or they would have learned it in a specific class, but I obviously realize that it's not the case. As of when can they do that? Can they learn that? Should we start in high school? Should we start earlier?
Yeah, no, Marilyn, that's a great question. Yeah, so I think that's one of the challenges, is that teachers, because they, again, I don't want to be too critical, but and yet respectful, is that teachers are not getting this kind of training when they're pre-service teachers, when they're doing their undergrad. And yes, so thinking about this, you can start modeling some of these, probably in late elementary, but definitely, here we call the middle school. So, around, grade 6, grade 7, right? Even earlier, the earlier, the better, right? And one thing that is interesting about your question also is that we don't really know, because there is actually no research on this, that kind of modeling, how far in terms of how young can they be to really understand that kind of modeling, right? Does that make sense?
Yes, definitely.
Yeah, absolutely. Yeah, because like you said, it's the assumption it's somebody else's job, right? So they go to CEGEP, right? They go to university, the assumption is that, of course, you've learned this when you're in high school or in elementary school. Well, no, they didn't, right? And one of the frustrations I had, for example, when I was at another university and I used to teach a basic educational psychology class, is that they got rid of educational psychology, where we just talked a little bit about metacognition. And I'm like, how can you be a teacher and not know about the psychology of learning? That's like me, oh yeah, I'm going to be a surgeon, but I don't know anything about anatomy. It's like, are you kidding? Right? So, yeah.
Is there much knowledge on like how much they need this to be modeled in different disciplines? Like you might think they might learn it in one area and then we just assume it translates into reading a physics textbook.
Yes, so that's a big open question. Yes. So for example, the modeling I did, I mean, this is, this is chemistry, right? Yes, but now if we replace this, with a physics question, 3 physics paragraphs and a let's say a pulley diagram, right, or an inclined plane diagram, does it still apply, right? And so that is interesting because that's related to the most difficult part of metacognition, which is actually captured in the MAI. It was the third part, is the conditional knowledge, right? You get to model this for me as a learner. I get to practice this. Now I'm becoming much more metacognitively aware and a better regulator. But now, can I transfer that to physics, to biology, to history, perhaps, to economics? And that's still a big open question because not many people are doing this kind of, does it transfer to different domains or tasks? Mm-hmm.
I think that little intervention has really helped, at least it's helped me to understand how I could do this better. Hoping that others also feel that it's helping them think about it. There are some questions that are, or comments being put onto the chat, but maybe not to stop your flow, Roger. But I'd love for us to come back to this maybe after you sort of get a little bit more. Thanks.
Yeah, absolutely. No, please don't apologize. I mean, I want this to make this as interactive as possible. So, and so to answer some of these questions that you have posed now is, whether, for example, even showing students their eye tracking data, right? Because imagine it's this first paragraph that is the most critical. And imagine, right, this is the beauty of technology, right? Not just, for example, a game or a simulation, but the fact that if you have now eye tracking data, now here's the other issue for metacognition and self-regulation, is that students, right, we as students, now if I think myself as a learner, right, we never get to see ourselves as learners. It's always through somebody else's eyes, right? The teacher, the peer, the tutor, the parent, right? And here, now imagine I'm able to confront, if you will, not in an adversarial way, but I get to see my own data. Right? Does that help me understand? It's like, oh, well, of course, now I see why I didn't get that matrix correctly, right? Nobody ever sees that, So, for example, a MetaTutor, right? I'm going to show you a little bit is that, so in terms of the design, when we designed this, my gosh, over 15 years ago, right? We did this when I was at the University of Memphis, then we carried on this to McGill, where we collected data on McGill students. We have collected data on Memphis students, North Carolina, Raleigh. So then the question is, if you know the principles of metacognition and the principles of self-regulation, is that we actually spent a year not only trying to figure out what the interface was, but build environments. So for example, there's a reason why there's a timer, because students were given a minute to learn all they can about the human circulatory system. And so, if you are a good self-regulator, then you should be checking, right, how much time, how many goals, and how much time, and how you have left to be able to complete your task. We also developed this system, right? This system has a table of contents, very kind of old school technology. But guess what? Because with eye tracking, we can figure out when does a student go to that area, and we can make an inference that they're monitoring how much time they have left on the task. In the table of contents are not open, right? Because the students are setting a goal. And one goal may be, I want to learn about systemic circulation. Perfect. Now the system can track you. Well, guess what? You're going to have to click and subclick on all the content, because now that we know what goal you have to learn about the systemic circulation, we want you to be explicit, because every time you search for something in table of contents, you are going to get some text and diagrams. We want to figure out if you are metacognitive monitoring. So let's say your goal is to learn about systemic circulation, and all of a sudden you're reading about systemic, circulatory system in non-humans. If you're an instructor, you would say, well, why are you reading that? Right? Well, what we do is we let them. We don't intervene very heavy-handedly. We know what the average reading is for our college students. And once they reach that threshold, then an agent, here's Mary the monitor, the agent pops up, and she still doesn't say, hey, stop reading that because that's not relevant. She actually asks you a question. Do you think that that content is related to your learning goal? Right? And the student now has two choices, right? The right choice is, no, it's not relevant. You know what? I'm going to go back to the table of contents and find something, in which case there's no need for more intervention pedagogically. If the student says, yes, this content is relevant, then the student is forced to justify to Mary the monitor, why do you think this content on non-human circulatory system non-human is related to your wanting to learn about systemic circulation? So now we have that going on. We also have a self-regulation palette, because students are taught about a few, not all, learning strategies, which are the control and metacognition, so that they can also indicate to the system, hey, now I want to take notes. Is it because you've been reading quite a lot, trying to integrate text and diagrams, now you're ready to take notes? Or they can also say, hey, I know this. That's great. That means you're engaging metacognition, because if you know the content, right, then there's no reason really for you to spend time more on this content. So there are ways that systems can be designed, educational training systems can be designed to either to trigger, to foster, but also to collect data on students' processes, which at some level have some level of AI that can actually intervene, right? Because part of our infrastructure is that we're also trying to use artificial intelligence to do what an instructor would do if they're not absent, right? So here's an example of, this is just an overview of MetaTutor.
Welcome to MetaTutor. MetaTutor is a hypermedia environment which uses text and diagrams to help students learn about complex science topics like the human circulatory system. The main purpose of MetaTutor is to help students learn to better self-regulate their learning by deploying appropriate planning, monitoring, and learning strategies. MetaTutor interface consists of different parts. The content area is where the learning content is displayed through the session in text form. Learners make metacognitive judgments of their learning at different times during the session. Students can navigate through a table of contents at the side of the screen to go to different pages. The sub-goals learners set are displayed at the top middle of the screen, and they can manage sub-goals or prioritize one here. A timer located at the top left corner of the screen displays the amount of time remaining in the session. The overall learning goal is displayed at the top of the screen during the session. A list of self-regulating processes are displayed in a palette at the right-hand side of the screen. Students can click on them throughout the session to deploy planning, monitoring, and learning strategies. Static images relevant to content pages are displayed beside the text to aid learners in coordinating information from different sources. Text entered on the keyboard and students' interactions with agents are displayed and recorded in this part of the interface. 4 artificial agents help students in their learning throughout the session. These agents include Gavin the guide, Pam the planner, Mary the monitor, and Sam the strategizer. MetaTutor is designed in a way that all interactions of learners with content, agents, and the learning environment is recorded in logs for further detailed analysis.
Are there any questions before we proceed?
Kathy, did you want to ask yours?
Sure. Yeah, I have a couple. One really quick and easy is whether these tools are sort of widely available or if it's just for research at this point. And the second is relating to cognitive apprenticeship, because the sort of modeling process that you were showing us and talking about reminds me of that. But I mean, in terms of disciplinary thinking, is it the same processes? Where do those kind of intersect?
Yes, so absolutely, Kathy. Thank you for your question. And to answer the first question, most of it is being used as a research tool. So we have colleagues here, we have colleagues in India who are using it with engineering students. And then the most extensive work that is still being used actually is in the University of Oviedo in Spain, where our collaborators actually have a Spanish version of MetaTutor. They've developed a Spanish version of MetaTutor, and they're using it with learning disabled college students, which is an area that we have never really focused on. So it's not, so one question is that, no, it's not being widely distributed, but that's something that obviously we would love to do. And then for your second one, yes, so cognitive apprenticeship model. So there are aspects of cognitive apprenticeship model, but there are also limitations in terms of parts of the cognitive apprenticeship model, especially, for example, reflection, that are going to be very challenging for our original agents to be able to do that for the student, or get the student to do that for the system to understand about the quality of students' reflection about their metacognition. Does that answer your question, Kathy?
It does. Thank you.
Okay, thank you.
I don't want to jump in with another question,
Yeah.
but I'm just curious about how successful is this when students who are, let's say you have some way of knowing what level the student is in terms of their use of self-regulatory processes. Do you see improvements, or are improvements sort of dependent after using these kinds of tools? Is it dependent on other factors?
Yeah, no, great question, Liz. Thank you. Yeah, so we spent, in fact, I'll share a paper with you. We just published that synthesis of the last 15 years of work on with MetaTutor. So in terms of the cognition, metacognition, emotions, and the little we've done with motivation. There was one of my grad students at McGill that was interested in motivation. So we do use students' prior knowledge, for example, and other measures of motivation and self-regulation that are administered at pretest to be able to predict, right, how much they've learned. So we know, and we also have two versions of MetaTutor. One is the control condition, and one is the adaptive condition, where they actually get feedback and scaffolding from the agents. So of course, the experimental condition, which is the version, which is the one with scaffolding, always outperforms the students who get the control condition, where the agents are present, but they don't really do much for you. And those are usually measured. So the impact and effectiveness is always done kind of immediate pre-test and post-test kind of thing. We have tried to do 5-day studies where students were coming back to see also if they were developing self-regulatory skills and better metacognition. But here's the problem, right? The problem is that because this was originally designed as a research tool, we are really at the beck and call of instructors, whether they're college professors, right, or middle school or high school teachers, because the question is that now you're impeding or intruding on instructional time, right? And no matter how much we paid, for example, in the cases where we actually paid participants, it was so hard to get people to actually come back for even after 3 or 4 days of interacting with MetaTutor. So tools like this, right, to really have an impact in terms of a long-term impact, if you will, and to really foster the development of self-regulation, this is where a researcher or research team like ours would have to really work collaboratively and intensively with a faculty member who really want to use this, for an entire unit, right? For, let's say, 2 weeks, 3 weeks, right? Or even throughout the semester. If that makes sense.
Because there's a lot going on in MetaTutor at the same time. Is there, how do you account for things like I don't know, like the multitasking that has to go on when you're switching back and forth from like trying to learn to going to metacognition, but it is no longer meta. I mean, it's meta, but it's not running subconsciously. You're like consciously being asked these questions. So it's very active, switching back and forth between these tasks.
Yeah. So we do is we collect, so let me show you an example. I'll answer that by, so one of the way to tease that apart is that we use multimodal data, right? So here's an example. I'm going to show you a video of, let me just start the video for a second, and then I'll show you what you're about to see. Let me just pull it. So in this case, right, this is a case of we get to see, so think about this obviously from a research perspective, but this can be from a teacher's perspective. We get to see their face, so we get to see facial expressions. You're going to see the red ball right now. The red ball is over one of the agents, so you get to see their fixations, their eye tracking. So the longer, the bigger the circle gets, that means the longer fixation, right? And what you're not going to see here, I'll see you on another slide, is their physiological data, etc. So what we're looking at is, can we tease those processes, everything from multitasking, right? Which, if you are monitoring, that is part of being a good self-regulated learning, is that you're able to monitor the different aspects of your instructional content, in addition to the actual instruction, because you have to learn, right? So there's multiple levels, if you will, right? And then, so yeah, so let me show you this. Let's see if this thing is going to work. I hope it works.
Let's set up some sub-goals.
All right.
So they talk, and it's been annotated.
I'd like to learn about diseases of
So the student sets their own sub-goals within the boundaries of the
Great. Did you want to learn about malfunctions of the circulatory system?
Yeah.
So she's constraining it.
Wonderful. We've just set up a good sub-goal.
So now he's looking to see,
Okay,
right?
yeah, let's look at platelet diseases, circulatory system diseases. This looks like it'd be related to malfunctions of the circulatory system. Hemophilia. Okay. Hemophilia is a bleeding disorder that results from a genetic deficiency in the coagulation pathways, causing uncontrollable bleeding. First, I should note that this is relevant.
Do you think this page and image are relevant and appropriate to your current sub-goal of learning about malfunctions of the circulatory system?
Yeah, this is definitely relevant, and so is the picture. Both
Great.
are relevant.
I agree. Why don't we go ahead and read this page and be sure to use some good learning strategies and monitor your understanding.
Yeah, so we'll start out by doing some notes. I'll move this up here, make it a little bigger. Okay, so we know that hemophilia is a blood disorder. Hemophilia is a blood disorder. It's related to uncontrollable bleeding. All right. I think that's a pretty good note. And
How well do you think you comprehend the material on this page?
I think that I'm pretty good. I feel pretty confident. I think I understand this information.
Let's now take a quick quiz on this content to make sure you understand it. Awesome. You were right and did a good job on that assessment with 100% of correct answers.
All right.
You clearly seem to know this part. We should consider moving on to another page.
Yeah, that's a good idea.
So does that help exemplify the question you were asking?
Yeah, that's really interesting.
Okay, yeah. And of course, the avatar, I mean, she's a little, so then there's the delay because, it's like he's ready to move on, right? But she still has to give her script. And that's something that, could potentially, sometimes it frustrates some students, right? Because like, I'm ready to move on, but she has a script and she's got to be very explicit, right? And there's a reason for that. So that synchronicity between what the student wants to do right away in real time and versus, what the agent has to deliver. So, yeah. Okay. Other questions, or do you want to see some more stuff? How do you tell me?
Let's see some more.
Okay. Well, I don't know. Behind door number 2. No, I'm just kidding.
Let's set up.
Yeah. All right. So what I want to show you is, So this is what a typical setup looks like, right? So we're collecting physiological data on the students, or looking at the level of arousal. So we know what the student's baseline is, right? And then the question is, so let's say that, Mary is giving you, some feedback about your metacognitive, and let's say there's a spike in arousal. The question is that psychologically relevant, right? And should the agent intervene? And if they do, then what are they supposed to do? Anything they're typing, anything they're clicking on is collected as a log file at the millisecond level behind the scenes that we collect. Here's an eye tracking tablet. Okay, so the eye tracker basically is what allows us to keep, to understand what they're paying attention to for how long, right? What if they're going back and forth. There's dialogue, there's a table of contents, and we also have screen capture. So, for example, we use Camtasia or other screen, because we need to have context. If we're going to make inferences about students learning, then we need to understand what were they doing. There's a timer, right? And then we have just kind of a, it's just a Logitech camera that basically is capturing the face, and then behind the scenes in real time is actually doing facial recognition. So we're very interested not so much in the basic emotions of the humans, right, which is like anger and joy, but the ones that are more associated with learning. So we're looking for, can we detect boredom? Can we detect confusion and frustration? Because we know that if none of those actually are, if we don't intervene as instructors, right, or pedagogically, then that will lead to basically cognitive disengagement. And once that's done, then game over, right? And then the other thing is that, in this case, you have an agent. So here's a different, so that's the kind of data that we collect. When we go into classrooms where we have 30, potentially 40 people, the only thing, sorry, before we do that, is that the only thing you don't see here is that there's no labels. So sometimes we collect concurrent verbalizations, which to us really are the window into the mind, because that's when you're revealing exactly what you're doing. We're basing it all on language, right? But that's the kinds of data that we collect. Here's an example of another system. This is actually a very, even more, if you will, more primitive system, which is with our College of Medicine. And these students are given 5 cases, right? In the blue, there are 5 cases of cough, and they have to basically provide a diagnosis, which is the green. And there are 5 tests, right? They have to basically match, which of these test scores, lab results, et cetera, relate to each of these patients, and then also the symptoms. And so what I wanted to show you here is that, this is the live data of a actual second-year medical student solving these 5 cases, right? So in this case, you see the eye tracking, it's a lot more faster. That's because this eye tracker is actually even more sophisticated, sampling at a higher rate. You can see what they're circling, right? As we tell them, hey, pretend you use, the mouse as if you were using your a pen, right? And at the same time, what you see down here that looks like an EKG is actually not an EKG. This is the intensity, if you will, of the different facial expressions. See, the first one is anger, then they have content, they have fear, disgust, etc. That is based on the camera, because we're also trying to figure out, because these cases are actually very complex, we're trying to see what role negative emotions play in diagnostic reasoning process for these medical students. So just another example of additional data, if you will, okay? And so then the idea is to take this, right, the data, once we compare, because here we compare medical students to residents to faculty and clinicians, is how would we make, what kinds of support can we have to facilitate this learning for the students? So that's just another example. Just to give you a very, very short sampler, this is just 4 metacognitive processes. We have in other ways, applications on the documents, what it looks like. That here you have the description, but then you also have what typical students, how the typical students express these kinds of metacognitive processes. Some are easier to use and more appropriate given specific times during instruction, okay? And also some of them are actually more challenging to model from an instructional perspective. These are some models, And then here are some environments that have that focus on self-regulation. So you've seen MetaTutor. So my former advisor, Suzanne Lajoie at McGill, has been working with BioWorld. So here, trying to teach self-regulation to medical students as they learn how to diagnose cases with her system. We've done work with Crystal Islands, which is a serious game where you are a student, completely different environment, is that you're learning how to self-regulate by monitoring. What is Kim? Kim is the nurse. I can get to talk to Kim, the nurse, because there's been an outbreak on the island. All information is Kim giving me. I can then talk to the patients. I can talk to the scientists. I have a scientific worksheet. Phil Winnie over at Simon Fraser University has this other environment where you can bring any kind of content. As you can see, it's very hypertext-ish, if you will. There's some diagrams. And Phil is treating this like as if it was a digital notebook. So the assumption is if when a student highlights something, right, if they're learning, let's say, about astronomy, right, is that there is a reason why they highlight it is they found that it's completely, it's important. Our colleagues at Vanderbilt, Gautam Biswas and his colleagues, they take a different approach to teaching metacognitive self-regulation. They have this environment called Betty's brain. And Betty starts off, so this white box here starts off as a blank. And what they do is they get the kids to learn about ecology, right? And what they have to do is once they've learned about ecology, it's a learning by teaching paradigm. They go and populate Betty's brain by putting the concepts together and the relationships. And then they'll get another student to come and ask Betty questions. Well, guess what? Betty, my version of Betty can only answer your questions if I actually taught her something related to what you are asking. And so they go through loops that Betty can answer the questions. Sometimes they're partial answers. So that forces the kid to go back and learn some more and eventually build Betty's brain, right, in terms. So this would be an excellent assessment tool, but also a way of students representing what they've learned, right? Not to mention that, they get to have more active learning in terms of students learning by asking questions to Betty. And then this has actually an explanation where you can actually, all right, so I want to know about, how, for example, the chemicals in the water are related to the reason why fish are dying. This actually has an AI engine that can actually highlight, okay, the reasoning process and how the constellation, what part of this constellation of your concept map related to this topic is relevant to that question you've answered. So these are just some examples. So like I said, in the lab, it's fully instrumented. When we go to classrooms, whether there's kids, right, or adults, for example, in the CGEP level or university level, right, sometimes we get concurrent verbalizations, log file, and then camera, right? So we get, because obviously we cannot afford at this level. I mean, these are about $30,000. That would be pretty cost prohibitive, right, to bring camera eye trackers. However, there are ways of actually pulling the kids, right? So you can still potentially do the full instrumentation in a classroom if you were able to pull the kids out of the classroom into another area. We do work on teachers, pre-service and in-service teachers. What inferences and how do they analyze students' multimodal data? And then we also test other technologies. So here's an example of a completely different type of technology. This is tangible computing. So these two students are engaging in collaborative problem solving, as using their hands to move this kinetic sand that is a representation of a particular area, the coastal region of North Carolina. So you got the little houses here, the black dots, and the blue is the water. All right. And so the question is, so there's a computational model of the weather, and they have to use their hands to block. So as they use their hands to block the water from coming in, right? Because want to inundate people's houses, is they get near real-time feedback whether they're effective or not, okay? And in this case, this is where we test, how much level of arousal. They're both wearing a bracelet, right? Is there synchronicity between the two participants, the two students? We also test other tools such as an EEG. How much cognitive load is there? Because once this simulation starts, right, it works goes on for pretty fast, pretty quickly. And then in some cases, we also, instead of having it at the bar, which actually provides better and more stable and accurate eye tracking data on students, this one is they're using a portable eye tracker. So there's a little bit of noise in the students. And sometimes, we're stuck with, hey, we're going to a school where there is no lab. Well, guess what? Right? The kid is actually being tested in the classroom, okay? And we make do as best as possible. So here's an instrumented kid with Betty's brain, with Crystal Island. And so here's some of the work on VR. This is from a prep school here and high school kids. So we ask the same question, right? So here she is. We get to see what the student's doing because whatever she's doing in the VR environment is also being shown here. So our interest is to work with faculty and the teachers to figure out, like we want, imagine getting a concurrent think aloud or verbalization of the teacher, i.e. the faculty member and the teacher, who's the expert, in terms of, in a separate room, what is this student doing? Is this student actually learning? Is this student using effective strategies? How do we know the student is monitoring what they're doing as they're trying to synthesize new chemical compounds? So I'll just stop there for a second if there's any more questions.
Beth, did you want to ask your question?
Sure. It may be unrealistic, but I was wondering if there's any possible application of self-regulated learning to coursework when it's not focused on mastering basic knowledge, but on deepening understanding of the subject matter by reading articles or book chapters or viewing videos.
Yeah.
Is there a way we can help students derive the best new knowledge and understanding and context from readings or AV materials when they're on their own with a list like this of books and articles to get through?
Yeah, so I'm just going to make a correction. So all the examples I gave here, none of them are focusing on mastering the content, right? They're focused on conceptual understanding, which is even more challenging for students, right? Some of the other environments, so for example, this one here is really focusing, which I didn't mention because this is really focusing on mastering. This is algebra. It's a mastery oriented, which we find that, okay, that's fine, but that's very kind of low level and doesn't really replicate what students are really studying, if you will, even though it's important, right, to master material. But yeah, I mean, so for example, with MetaTutor here, it's really about conceptual understanding, right? But they're looking at types and diagrams, and it's still about, so the concept is that we're using a mental model, which I didn't share with you, is a mental model understanding. You know, are students shifting mental models of conceptual understanding, which are qualitatively different from a very naive understanding of the circulatory system to perhaps a more sophisticated mental model, the human circulatory system, where they actually have an understanding that the human circulatory system and the respiratory system are working in tandem, right? So yes, so these systems go from mastery to high-level conceptual understanding, which is the most challenging aspect of learning. But the question is that has not really been addressed is, if we are to train students and teach students how to self-regulate, then, you know, is it not just, as we were talking about, domain relevant or domain topic specific, right? As I was modeling, for example, the other example with the other version of MetaTutor, does it apply to physics, etc. But as you scale up the complexity of learning, if we think about mastery learning as kind of the lowest level to conceptual understanding, right? What is that transition, right? In terms of teaching, right? And acquisition and the teaching and instruction of self-regulation and metacognition, how does that change as we go from mastery learning all the way to conceptual understanding? And are there particular phases that we need to do for students and engage students in? So, does that make sense?
Yeah, it does. I'd be interested in finding out what they are in some future seminar, perhaps.
Okay. Yeah.
Thanks, Roger. I'm looking at the time and I see we have 2 minutes. So was there, Sue, do you want to post the survey one last time? And I would guess that means, Roger, was there something else you wanted to share with us before we wrap up, or did you want to take one last question? It's up to you.
Yeah, I can take one last question if that's okay, because I got multiple slides, but yeah, take last question if you.
I'll just wait a sec. Liz, did you have one? I've got one too, but I don't need to
As
ask
many
mine.
questions as you want to go ahead.
No, that's okay. Go ahead, Liz.
No, I was just about to say that there's so much that I feel like I want to continue asking. I think perhaps Beth's
part 2 if you want.
Yeah, exactly. Beth has hinted at, maybe we should have a follow-up
Okay.
because this is really very, very deep. And there are many things that that I want to ask, but Phoebe, you go ahead and have the last question for at least the formal part of this.
Oh, I think it's okay. I think mine can wait.
Yeah. But Liz, I'll
I
be
think
happy
Liz,
to, oh, sorry.
go
Sorry,
ahead,
Phoebe.
Roger.
Yeah, I'll be happy to do a second, a follow-up, a second part to this. No, that's not a problem.
Oh, thank you. Okay, so
absolutely.
we have it, and so Phoebe, you go ahead. You ask.
Oh,
I'll
I've just
stop
because
my screen.
I made this note ages ago from the very beginning. So maybe I don't know if it's appropriate to ask now, but Roger, I was still interested in going back to what you were hinting at before with reflection, because it is such a term we use so much in professional development.
Absolutely.
And workshops that we run, but we don't fully know where it fits in with the metacognition versus self-regulated learning schemes.
Yeah, no, absolutely. And that's going to be a very long answer, but the short answer, hopefully let's do a second session. But the short answer is, you saw how explicit modeling is, right? So that students can learn how to do it. And of course they need practice and feedback. So what we have been thinking, and some of the teachers that we're working with, several high schools, is once that modeling is done, and we're collecting multimodal data, is to then think about reflection in let's rewind the tape and go back and actually look at the multimodal data and have this really rich discussion about, hey, look, at this point in time, right, we think that what did you think? It looks like you didn't understand because your face, your facial expression was that one of confusion. So, why were you confused about this, as they're looking at this? Because we would have the screen recording, the facial expression. So I think future-wise, multimodal data would be so helpful in really engaging in well, I don't want to call it true reflection, but real reflection, in that now you have an interaction between a faculty member or an educator, right, a teacher and a student, right? And they're actually, look, here's the video, right? We're using Crystal Island, and you were confused for like the next 3 minutes. And so let's play that tape. Now we're both doing this. All right, let's stop and all right, do you want to share why you were confused? Because is it because I can see from your eye tracking that for example, you kept persisting on this particular paragraph and you were doing nothing but that, right? So is it the complexity of the text? So I think it will allow and really facilitate the reflection process. Otherwise, it's just verbal, right? And I know, and we have nothing else but verbal, right? Even like feedback, it's always verbal. Well, show me my data. And I think that would be so useful, because that would help not only the learner, but also imagine the faculty, how rich that is, right? And you don't have to do just one-to-one, but imagine doing it in front of the class. You're projecting that. Right, and we're having now a class discussion about a particular student's data, for example, right? And maybe imagine comparing it to your own data, right, as the expert, right? Well, this is how I monitor, right? And look at my eyes. Look what my eyes are doing, right? That kind of thing. So I think there's innovative and transformative ways to enhance the reflection process using multimodal data, especially when we think about conceptual learning, right? That is so hard to teach and so hard to assess.
Thank you. And thank you for everything.
Oh, no, this
was really interesting.
Thank you for the opportunity. Yeah. And yeah, seriously, Liz, I mean, we'll be happy to do a second, maybe we can start with questions that, unfortunately we didn't get a chance, and then kind of dive deeper. I mean, I got some other examples using other technologies, but yeah, if you want.
We have you on tape, so we're
Uh-oh.
I think we would all love this, because if I were to say one thing, there are a couple of things that I believe that are truly critical for any kind of learning. One of them is this notion of being able to be self-regulatory. So, if it's the foundation, and it's one of the things that we have to learn how to teach, I think we all need to know about this. So, so thank you for sharing, and yeah, by all means, please, for those of you who are here, please let us know what you want to know because that would be really useful. Because when we bring Roger back, we can, as he's suggesting, we can start with some of those deep questions and see more about how we can bring this into our classrooms and how can we model it. And then for those who like research, Roger is obviously an incredible researcher, and that's his focus. So maybe we could offer our classrooms as spaces for you to explore and for us to learn about how to really get some benefit from this from these tools.
Yeah, be glad to. Absolutely. Thank you for the opportunity.
Well, thanks again.
Thank you. Well, thank you all so much, and thank you so much, Liz, for inviting me in.